All right, this is the video for section 3.5. This is pretty short, really. Here we're solving systems. So that means there's two equations. We're trying to find out where the two have in common. So you're going to have two types of problems. You're going to have some where one of them is a quadratic, like here. One of them is a quadratic, x squared, and one of them is a line where there's no squared. So there's three ways, though, because those can intersect. They could be like this, where they don't intersect. So you get no solution. You could have one where the line just touches the parabola in one point. Here it's at the vertex. It could be on somewhere else too. So one solution, and some that have two solutions. So that's if you have a parabola and a line, so a quadratic and a linear. Now if you have two quadratics, you have three choices. They could be like this, where one's up and one's down, and the up one is above the down one, so they don't touch, no solution. You could have one where they only intersect at the vertex, so one solution. And then your third one is if they're up and down, but the vertex of the down one is above the vertex of the up one, like this, so they intersect in two things. So you could have three possible ones. So either one, you could have no solution, you could have one solution, you could have two solutions. Now we're going to do them two ways. We're going to do it by graphing and by substitution. By graphing, we're just going to put the equations in our calculator, and then we're going to find the intersection of the two. So that's by graphing. So these first two are by graphing. So we have those two. We're just going to put those in our calculator. So on your calculator, go like on your graph on here. Let me get rid of that. So we put them in there. So x squared minus 8x plus 12. So we'll just put that in our calculator. X squared minus 8x plus 12. So put one under y1. Go down and put the other one under y2. So 4x minus 24. 4x minus 24. Okay. Now we're going to graph those. Again, when I first graph it, depending on what you did, I like to hit zoom 6. So I'm going to hit the zoom button up here in the upper middle, and then number 6 just to get my graph. So you can see that first one, y1, that was a parabola. The second one is a line. So you can see there where it looks like they're crossing somewhere over here. So if we want to find that point, we're going to do second calc intersect. So on your calculator, you hit the second button. So hit second. And then up at the top, where it says calc, there's your menu. Well, we want to know where those two intersect. So I'm going to hit number 5 for intersect. It's going to ask me 3 questions. First curve, well, we only have 2. If you look, you can't see my cursor right now. But see, it's on the parabola right now. So first curve, I hit enter. See, now it jumped over. You can see it now. It comes into screen here. See, now it jumped over to the line. So that's our second curve. They do that, so if you have a bunch of them on here, you can pick which 2 you want to intersect. We only have 2, so it doesn't matter. So I hit enter. Now for guess, you can go somewhere near where it looks like they cross and hit enter, and it'll tell you the point of intersection. That wasn't so good. So here, even though these look like they intersected, they actually don't. That's why it says error there. Error, there's no sign change. That means they didn't actually cross. So this one is no solution. They come really close. If you go to the point like 6, 0, they almost touch at 6, 0, but they don't quite. Okay? So let's try the next one. So again, go to y equals, clear those off. I'm going to put the first one. I checked that other one twice because you never know if you made a mistake somewhere. So here I'm going to go x squared minus 2x minus 1. And then the other one is negative 2x minus 1. So we graph that. Again, the first one's a quadratic, so it's a parabola. The second one is a line. So again, second calc. We want to intersect, so number 5. Again, the first curve, you can see it doesn't really matter. See, right now it's on the parabola. So I hit enter. Second curve, it jumped to the line, hit enter. Now it says guess. So I'm going to go somewhere near where it looks like they cross and hit enter again. It says their intersection is negative 2.08, negative 0.9998. Now notice that negative 2.08, see how it has an e to the negative 7? That means that's actually a negative 0.6 zeros and then 208. So that's almost 0. Notice the y1, that's pretty close to negative 1. The actual intersection point here is 0, negative 1. For some reason, the calculator does that. So this intersection point is 0, negative 1. Again, whenever you see that, see how it's e to the negative 7? That means times 10 to the negative 7. So that's like if you took this and put a decimal point and then 6 zeros and then 2082. So that's really, really close to 0. Here, negative 0.9999996, that's really close to negative 1. The actual point is 0, negative 1. If you plug 0 in here, 0, negative 1 is on both of those graphs. Okay? So that's by graphing. Those are a couple of strange ones. Now, by substitution, it takes a little longer. Here, if I tell you that y equals x plus 4 and y equals x plus 2 squared plus 1, if they both equal y, by the transitive property, shouldn't they both be equal to one another? That's what we do by substitution. We want to find out where those are equal. So we're going to take the first one, x plus 4, equals the second one, x plus 2 squared plus 1. So we set them equal to each other. That's where they'll cross, where they're equal, where their y values are equal. So now, let's see, if I distribute that out, that's going to be x squared plus 4x plus 4 plus 1. Now we want to get it equal to 0, so I want to move both of those to the other side. So x squared, 4x minus x is 3x. This will be 5 minus 4 is plus 1. Now we have choices. If you look at this, this won't factor, so you might want to use the quadratic formula, which we just did in 3.4. So x equals a negative b, that's a negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 1, all over 2a. Well, that's a negative 3 plus or minus, this would be 9 minus 4, the square root of 5 over 2. So what that means is this intersects at two places, where x equals negative 3 plus radical 5, comma 2, and negative 3 minus radical 5, comma 2. Well, you could do that different ways. So let's find the decimal for each of those. So on your calculator, let's take a negative 3 plus the square root of 5 and divide it by 2. I get a negative 0.382. Okay? Now, if we plug that in to see our first equation was y equals x plus 4, let's plug that in here. If we take a negative 3.382, that was our x value plus 4. So on your calculator, you can just hit plus 4, and that gives me 3.618. So that's 1 point. Now let's do the minus part. So on our calculator, let's take a negative 3 minus, let me clear that off, a negative 3 minus the square root of 5 divided by 2. So that's a negative 2.618. Okay? Let's plug that into this equation. So that negative 2.618 plus 4. So on our calculator, where that's still on there, just hit plus 4. I get 1.382. So those are our 2 points of intersection. So once you find the x value, plug it into whichever one's easiest and find the y value. All right, let's try this next one. Now here, notice the y is intermingled with the excessive. So the first thing we're going to do is solve for y. So like this one, let's move the y to the right side and let's move that 5 to the left. So that'll be x squared plus 2x minus 5 equals y. On this one, since the y is positive on the left, let's move the 2x. So that'd be y equals 7 minus 2x. So again, if y equals this and y equals that, We want to know when those two are equal to one another. So set the first one, x squared plus 2x minus 5, equal to the second one, 7 minus 2x. We want it to equal 0, so I'm going to add 2x to this side, x squared plus 4x, and I want to subtract 7, be negative 5 minus 7 is negative 12. Now this one, if you look, I think will actually factor. Are there two factors of a negative 12 that if you put them together you get a positive 4? Well, two factors of 12 are 6 and 2. What if we used x plus 6 and x minus 2? So if we set each of those equal to 0, we get x equals negative 6 and x equals 2. Again, if we plug them in, let's say we plug them in, like here, we have this equation here. What if we put negative 6 in there? If I put in negative 6, that'll be 7 minus 2 times negative 6. That would be 7 plus 12, so 19. What if I put 2 in there? That'd be 7 minus 2 times 2. That'd be 7 minus 4. That's 3. So there's our 2 points of intersection. So that's solving them by graphing, solving them by substitution. And that's all there is to 3.5.